Welcome back for the second part of the RGB Heart project. The board can be programmed over the air, but for the first programming we need to be physically connected. The datasheet of the LED is in Chinese and it seems to say each channel consumes at most 12 milliamps. So 12 milliamps times 3 channels times 18 LEDs equals 650 milliamps, which is below the typical 1 amp that USB ports can handle. Just playing safe, I will power it with a typical fast charging smartphone charger. As I have a power meter nearby, I will make some power measures after also. Time to connect the USB to serial model to the board and to the computer so the programming can happen. The schematic and the material needed are the ones presented. I will use the Home Assistant installed in a virtual machine as I showed in my second video. First, the versions I'm using are these ones for VirtualBox, Home Assistant, and the add-ons I will be using ESP Home and File Editor. You can adjust the icons in your left sidebar by doing this, and please activate the Advanced Mode option. Remember that you can check the IP address of your Home Assistant in the virtual machine window. Let's start the programming. In Home Assistant, open the ESP Home add-on, add New Device, click Continue, enter the name of the board and the Wi-Fi connection credentials. If you are not asked to enter the Wi-Fi credentials, it is because you already entered them before. In a moment I will show how you can enter it again. Select the board Expressive ESP8266 ESP12 Echo as it is basically the same. Hit Next, click in the encryption key to copy it. Hit Install, select the option Plug into this computer. This can take a while. For me it took almost 20 minutes, but my computer is not that fast. Click Download Project, select the folder to save the project. Click Open ESP Home Web. It is necessary to put the board in the download mode. This is in the programming mode. To do that, keep pressing the IO0 push button, then press the reset push button, and finally release the IO0 push button. In ESP Home Web, click Connect and select the virtual serial port of your USB to serial model. Click Connect, then click Install. Select the previously downloaded file of the project and click Install again. The ESP LED should start blinking. If the process fails, click Retry or refresh the ESP Home web page and start the process again. If everything went well, a message indicating the installation was successful appears. Click Close. Press the Reset push button so the model can restart. The model will appear online in the ESP Home add-on. To check the model status, click the Logs option. It is possible to find the MAC address, IP, signal strength and other information of the board. Closing the window and clicking in Edit, the model's code appears. The credentials of the Wi-Fi connection are stored in a file that you can access using the File Editor add-on. Click the add-on, then the folder icon, go into ESP Home and it is the file secrets.iml. From now on, all the programming will be over the air, so the USB to serial model will no longer be necessary. Let's control the built-in LED of the ESP model just to see something happening. After powering up the model, it should have the status online. Click the Edit option to see the code. We will add code at the end. Go to the ESP-OM GPIO switch page to see how to use this component. The code should be something like this one. We can install it to the model wirelessly. After the compilation, we should see the model configuration. I kept getting disconnected and disconnected messages. To fix them, I updated the Home Assistant and ESP-OM updates that I have skipped before. I did Settings, System, Updates, clicked the top right 3 dots, checked Show Skipped Updates and installed them. Then I updated the version of the ESP-OM module and checked if the error disappeared. And it did. Now it is possible to control the built-in LED of the model by going to Settings, Device and Services, RGB Earth Device and sliding the control. I want to control the device outside of the Home Assistant and even when there is no internet connection. For this, it is necessary to add a web server component. In the ESP-OM page, there is all the information to do this. Just copy the code, place it and install it to the device. To access the device in the ESP-OM environment, click the Visit option and you will be redirected to the device page. There you can control the built-in LED, for now. The other way it is to go through Settings, Devices and Services, click one device in RGB Art and finally Visit. Of course, it is possible to simply write the device address in the navigation bar. Now it is time to turn on the light. The NeoPixel Buzz Light platform of the light component will be used as it allows to control addressable LEDs. The ESP-OM pages are these ones. Do you remember I put a MOSFET circuit to completely turn off the LEDs? Well, this means it is necessary to define a power supply component that will be controlled by the light component. Every time the light is turned on and off, this component will activate or deactivate the corresponding GPIO pin that controls the MOSFET circuit. The code is this one. To control the LEDs, the code is like this one. It is necessary to indicate the power supply ID. Click Install. Did I mention you can find icons in this web page? It has so many. Let's make it more interesting. In the device Home Assistant page, we can turn it on and off. But if we click on the Earth icon, we can see more options, as adjust the brightness and select a color from a color palette. The thing is, if we visit the device's web page, it is only possible to turn it on and off and adjust the brightness. There is no color selection. To accomplish color selection, I will add a scroll bar using a template number. The ESP-OM page to get the example code is this one. Then, using the code of my fourth video, it is possible to select all the colors of the rainbow. The final code is this one. You can find more information about this code in the mentioned video. Uploading it, Giving it a try. The rainbow is here. The thing is, how can I go back to full white? For that, I had to add a template button to run the code that makes the LEDs go back to white. The template button example is in this page, and the code to control the light is in this one. The final code with the necessary modification is this. Uploading it. Put it white, giving it some color, and then voila, full white again. If other colors are needed, one just have to change the percentage values in the code. Just to be clear, you can control all of these using Home Assistant. I'm doing this because I'm trying to control the board directly. One thing I noted is by using Home Assistant, the response is much better, almost instantaneously. Now, colors are great, but is it possible to do more? Yes, it is. I will add effects to this heart. The information about effects in ESP Home is in this page. There are a lot of examples to copy and paste, but it is possible to customize them and create your own. I will add 4 effects. First, the rainbow effect that creates a moving rainbow over the whole LED strip. Just copy the code and paste it in the light component. Delete the first line, the one that does not show the customizable parameters, because we may want to change the values. Next, who doesn't like fireworks? Just search for fireworks, copy and paste the code after the previous one. For a custom effect, I will do a pulsing color. Search for lambda effects to see the structure. My code is as shown, and in every 50 milliseconds it updates the brightness of the heart. Finally, I will adapt the code I wrote to select any color of the rainbow to make a color transition effect for all the art. The code is this one. I forgot one thing. In the fireworks effect, change the parameter use random color to true so different colors appears. Let's program the board and see the result. This time, when I click in the art, I will see the effects just added. In this one, we can see that Home Assistant updates immediately the brightness, and it's possible to change the color that is getting brighter or darker. Also, in the color transition effect, Home Assistant shows the color transitioning. As before, we can normally control the lamp. Going to the web interface, we have the same level of control plus the logs. Keep in mind that if the parameter for update interval is too small, it may slow down execution, especially if the control is happening through the web interface. In this case, the log output may be so high it will show a delay. To go around this, I will choose more carefully the messages that are outputted by the logger component, as disabling it entirely would conceal messages from the system that could be important. The information about the logger component can be found in this page. In it is possible to see that there are different log levels, so, generally, we want to see all messages except the ones that are blocking. Therefore, we look for the tag that is in excess and lower the level so only the more relevant messages are shown. In this case, the tags are power supply and light that are showing a lot of D for debug level messages. The code is something like this. We install it to the board. Now we can see that the messages being outputted are far fewer.